All right. It's my honor to introduce Dr. Ibrahim Bigley. So Dr. Bigley is the elder family Indo Chair of Computer Science and Cybersecurity at the Talitala College of Engineering, Department of Computer and Electrical Engineering, and Computer Science at the University of New Haven, specializing in cybersecurity and forensics. He's also a European Alliance for Innovation Fellow and a CT40 Under 40. He serves as the Assistant Dean and is the founder of the University of New Haven's Cyber Forensics Research and Education Group. Now, RB is also the former editor in chief of the Journal of Digital Forensics, Security and Law. He received his Bachelor of Science, Master of Science, and a PhD all from Purdue University, where he worked as a researcher in CERIAS. He's the program lead on the Center of Academic Excellence in Cyber Operations, designated by the National Security Agency, one of the only 12 programs nationally with the prestigious designation, and is also the principal investigator for the Cyber Corps Scholarship for Service program at the university. Now, RB is also the co-founder of the X Reality Safety Initiative. So with further ado, let's welcome RB.
Can you hear me now?
Got it.
All right, excellent. So I just want to say I think maybe it was miswritten. I think it's 21 universities that have the CAECO, because the ones that have it might not be happy if they see that in the video, like, oh, there's 21. Thank you for inviting me. Thank you for having me come out here. I gave a talk here when I was a PhD student in 2008. If you want to look that up. Of course, somebody's already looking things up as they're, coding or doing whatever they're doing on the laptop there. But I have more interesting things to say if you just want to give me a second. Unlike other people, I actually got all my degrees here. A lot of people say that you get inbreeding if you stay at the same university. I actually totally enjoyed being at Purdue. I think it's a great school, and you should all be very happy that you made it here and that you're part of the ecosystem of the various colleges and their cybersecurity initiatives. So I just want to thank everyone, and I want to thank Gene Spafford, who's done a wonderful job bringing CERIAS to where it's at today from back in the day. And without the support I've had here, I wouldn't be where I'm at. So today we're going to be talking about immersive virtual insanity is what I call it. And it's really about us exploring security problems in virtual reality. Has anyone in here ever used VR? Put your hand up if you played with VR. Put your hand up if you played with a new Oculus Quest. Newish? Nobody? All right, you should. It's pretty awesome. So I'm assuming some of you might have played with a Vive, right? Vive. Vive is pretty cool, but there's a lot of wires. You need a computer and all that stuff. But with Oculus Quest, for example, you don't need anything. I'll talk about that in a second. But I think I would not be doing justice to some of the things I'm going to talk about today without my students. These are all the students that have helped me work on this project, and actually, it's really their work that I'm presenting, so it's very important to give them the credit that they deserve. And today I'm only presenting about VR, but if you go online, you see some of our research. It spans all the way from drones to VR to blockchain distributed storage, child sexual abuse material investigations, and so on and so forth. But as any academic would have to, this work was funded by the NSF under this grant number. So it's very important for me to say that. And it's also important for me to say that my views do not represent them as the claim is presented here. So why VR? Why VR security? Why VR forensics? Look at the numbers. The market is expected to surpass 40 billion by 2020. The systems are becoming more mobile, with like the Oculus Quest, it's at $399. There's many untapped use cases, all the way from it being used in the medical world to it being used in social activities or anything else that you might think of. And so far, most of the research in this domain has mostly focused on what? On developing experiences, developing games, developing rehabilitation situations in virtual reality. And there's not really enough research on looking at where we stand in the cybersecurity domain in virtual reality systems that actually exist. So not theoretical research per se, but applied research. You go and you buy this piece of equipment. Is there anything in there that we should be focusing our attention to in terms of its potential security vulnerabilities? And if something does happen, can we potentially get the evidence from it? So the interesting thing about VR is there's some very interesting use cases, right? This is a very bad use case, right? And it also opens up research questions that span the computer science domain. So for example, if somebody was sexually assaulted in virtual reality, and they were not physically sexually assaulted, so to speak, what kind of things have to happen legally there in order for you to show a sexual assault case, right? So the interesting thing there is the fact that the person immersed in the virtual environment gets the same exact feeling pretty much that they would in the physical world. So you're really affecting that person's psychology in the virtual world, and it will have impact on them. So therefore, it's a problem. But yet again, there's another VR sort of use case that would be very helpful here, because VR has also been used in situational awareness to put people in situations that are where sexual assault might be happening around them, for them to explain to them how to deal with a situation. So there's some positive use cases, and there's some negative use cases. So what I'm going to be talking about today is going through the research program and some of the things that we did. So the first thing is, let's focus on exploring the cyber forensics of VR systems, meaning that can we extract any evidence from these VR systems should something bad happen? And then let's look at the underlying tech, but focus our energy on immersive VR. Because most people, when they know VR, they think of like a mobile device that they just put on their head and that's it, right? But no, VR is immersive. You could walk in the environment, you could move your hands in the environment, and that gets really interesting. And our purpose was to go and develop educational modules, novel attacks, tools, and other things in VR, but ultimately is to create some impact around this domain that would be useful.
Virtual and augmented reality. It's an estimated $27 billion market worldwide, and that is expected to catapult to over $209 billion in just 3 years.
Let's go into the tech world, where we're finding everything from medical to military to training applications to home use for entertainment. It's all exploding. While getting immersed in a virtual world is kind of cool, is it the next target for hackers? Here's WMAR2 News' Mark Roper with what it could mean for your family.
Dr. Ibrahim Bagili gets to play in the world of virtual reality as part of his job, but he suspects the trendy tech isn't just the next frontier for gamers.
Virtual reality is absolutely susceptible to hackers at this point in time.
The doctor and his cyber forensic research team at the University of New Haven say they've uncovered vulnerabilities in popular virtual reality systems. They believe the hacking will be different from anything we've seen before.
I think what's really interesting in VR is for the first time, we have a technology that takes over your complete sight and your complete vision, and now also is slowly taking over your hearing.
In the lab, researchers were able to take over systems and manipulate users physically. Graduate researcher Peter Casey says one way is in something called a chaperone attack.
The chaperone attack is when we either disable or expand the safety boundaries that are keeping the player from moving into any obstacles in the room.
In a human joystick attack, they were able to gradually move people across a room without them realizing it. Casey says it has to do with a false sense of reality.
Whoa! How did I get over here?
This, along with removal of boundaries, can be a concern.
You know, you could walk someone down the stairs.
The group also could turn on cameras and can insert or overlay images right into the middle of an experience.
What that is effectively a ransomware attack where they can no longer use the device as it's intended.
Researchers say there are very...
So as you can see, our work has resulted in us showing that there are actually new kinds of attacks that could potentially happen in VR. And while maybe the technology in terms of the attack vector might be still the same as any other technology, the impact is different. And we'll talk about this in a second. So you look at the different threat categories when it comes to VR, and these are the sort of high-level threat categories that we focus on. We focus on input protection, we focus on data protection, and we focus on output protection. We also focus on user interaction protection, when people are interacting with each other and how you can make that data safe between them, as well as the protection of the device itself. So there's multiple layers of protection that need to be involved whenever you're dealing with virtual reality systems. And the current state is that security is not that great in these systems, and it needs to be improved. So what is most of the work that's been done in this space? What is it about? Well, most of it has been things that focus on, items like input sanitization, right? What do I mean by that? Well, if you look at number 2 there, you see complete sanitization. So if you have an input from the external world that's going into, for example, your XR vision goggles or something like that, you can just take that out and remove it. Then the user wouldn't have to see it. If I'm looking at you as a person and I can tell who you are, what if we change the person in front of us to a skeleton, right? That way I don't get to see very important attributes about the individual that can make me identify them, just as an example. There's also been work that's been done on data aggregation and output protection, and obviously VR exposure therapy, right? If you're scared of spiders, let's put you in a VR environment and put you in, give you some big spiders that are going to crawl around you. Has anyone done that? No? All right. It's pretty cool. You should try it. All right? But until we started doing this work, there was no formal security analysis and forensics of consumer-grade VR systems. And that's really where our contribution kicks in. But before I take you on that journey, let's talk about let's talk about some VR jargon. Some of you might know this, some of you might not. Any gamers in the room? Yeah, so you know what Steam is, right? So Steam is the primary application, at least at that time, where you would download VR games and use your HTC Vive with and all sorts of things. So you can think of it as the Play Store for VR, but at the same time, it also acts as an intermediary between the VR and the equipment that you're using, okay? And that's where Steam VR comes in. So you have trackers, at least with the older systems, and we'll talk about the newer systems in a second, where they're mounted somewhere and they can track your movement, and you have the system on, it's connected to a computer that has some sort of GPU capability that would enable you to use the systems in the first place. Right, so trackers, lighthouses, head-mounted displays, and chaperone is the fake wall you create in VR, so you don't hit the real wall. If I had the headset on me right now and I'm approaching a wall, I don't want to hit it, right? And that's really the whole point of creating that fake wall, so you can see it in VR so you don't hit the real wall. Hello. Good morning. How's it going, man? Doing well? All right. So that's your job as an educator, is to get people focused, right? To make sure that what you're saying is kind of interesting. Now, you have inside-out tracking. You don't need to hang anything up. You don't need to do anything. You just put the system on and you go. That's it, right? So Ready Player Now is real, almost, right? And more importantly, the Oculus Quest was released, and about maybe a month or 2 ago, now they do hand tracking, right? So they can do real-time hand tracking and not just the joystick tracking per se that you have in your hands. They can track your hands, they can track your fingers. So now you can live a VR experience where things are more trackable, right? So from a privacy perspective, think about all the data that's being collected as this is happening. So one of the first things we wanted to do is to see what kind of artifacts we can pull from these systems in order to show, for example, if something had happened and why it happened. So maybe a crime was committed, right? Maybe you walked into a room, and I always tell people this. If you don't like your husband, buy him a VR system, put him in VR, and now they can't see anything. Just go and whack them on the back of the head, right? So from me as a cybersecurity person, I'm always looking at all the attack vectors. And I think that VR is the perfect time to kill somebody, as crazy as that sounds. Now, hopefully that doesn't happen while this is recording and it's going to be playing. And don't censor this because I'm saying it, But hopefully no one's going to take that idea forward and then I'm going to be blamed for it. But it's the perfect time, right? So what artifacts can you create? And we have a project that was funded by DHS called the Artifact Genome Project that was launched in 2017. And I'm just going to show you a quick video so that maybe you'd want to use it in the future.
Joan in London, Joe in Switzerland, and Mark in the US are all digital forensic practitioners struggling with the same problem. They have to rely on their own past experience in manual digital forensic analysis in order to find evidentiary artifacts. And every device they work with has different forensic artifacts, making their job that much harder. What if their knowledge was gathered? And what if these artifacts could be tracked and updated over time? Introducing AGP, a unified digital forensic curation platform that brings forensic practitioners together like never before. Investigate, upload, share.
So if you're a student or if you're a researcher and you're interested in seeing these artifacts, subscribe to AGP and you can gain access to that data. So our job initially was to look at the security and forensic analysis and focusing more on the application layer and seeing what we can get at the network, what we can get in RAM, and what we can get from the disk. And that was kind of our initial sort of work. So this was the first paper we presented at SADFI, which was a workshop at Security and Privacy. And what we did is we analyzed all the social apps in the VR market that we thought were highly used. So prior to this work, a lot of my work is focused on mobile apps. So we did forensic analysis of, for example, WhatsApp. We did forensic analysis of, all of the social sort of messaging applications, as you say, Facebook. We did Twitter. We did all of them. And my mindset, as a researcher, I'm like, what's the next thing? How are people going to socialize in the future, right? I mean, we're all stuck with our phones, and there's people in this room stuck to their laptops right now, right? That's what we do. We're screen people. And all we're doing is we're bringing the screen closer to our eyes. That's where we're moving. So essentially, if you have a VR system on, you're going to interact with another person somewhere around the world, watch a movie with them, go out on a date, right? That's where we're heading. So that's what we did. And we were the first people to take a closer look at them. So we basically set up an experiment where we set up 2 different VR systems, had the people log on to these apps, use them, so that we can generate some data and see where that takes us. So to give you a quick overview, these are just some of the artifacts that we were able to recover, right? So we can tell a lot of things. And this is just from the Steam side of things, which is this app store that I was talking about. All right? We know when people logged on, we know when they're logged off, we have access to all this data potentially from the system. There's also an app called Big Screen. Has anyone heard of Big Screen? Right? So Big Screen is this app where you could basically watch a movie with someone else around the world. If you want to watch Netflix with somebody who's in New Zealand, you can do that, right? So that's kind of the idea behind Netflix. And we were able to extract all sort of artifacts from there. There's also Rec Room. You can see, we know when people fail to log in, when they open the application. Facebook Spaces. So one interesting thing about Facebook Spaces, I'll tell you about it later because I don't want to say it on video, but I'll tell after the talk, come and talk to me and I'll tell you in person. But we were able to extract artifacts there. But really, the main findings is that we're able to extract artifacts which can tell us the who, the when, the what, and the where of when something potentially could have happened in some of these VR apps. And that's good. Because if you resulted in something being, if some crime would have happened in VR, then we can kind of reconstruct the events and be able to see what happened. And that's really amazing. But I think the real cool thing is when we started looking at the net flow, the network traffic, we started realizing that some of this stuff is unencrypted and unauthenticated, right? So from a hacker's perspective, you get really excited and you're like, what can we do next? Right? And this is when we realized that there might be some man-in-the-middle attacks that we might be able to do on some of these things, and we kind of got excited about that. So our next paper was published in IEEE Transactions on Dependable and Secure Computing. And our goal here was to understand a little bit more about where we can attack at the VR layer to potentially cause the most damage, all right? So looking at these diagrams right now, is it clear on the screen? Can everyone see it? Yep. So if you were an attacker, where would you want to attack? At what layer would you want to attack? Like the easiest sort of layer to attack at, where would it be? Come on, give it a shot. You have 1 out of 4 chances. So try. Yep.
I'd say the device drivers layer, which is not in the hands of the consumer, perhaps.
Well, so that's a good point. It's a good layer to attack on because you might have much larger coverage in terms of your attack surface. The only problem is if you ask the consumer to install a driver, there's going to be all sorts of warning at play. Correct?
Yeah.
Like, did you ever try to install a driver on a system that wasn't, the driver was modified or something, and it's just going to give you all sorts of error messages, right? So it's not really the best place to attack. It's the best place to attack in terms of attack coverage. But if you want to go quick and get your job done, where would you go? So this is what we attacked on. We attacked on the open VR layer for a multiple of reasons. One, it's open, so you can see the source code, right? That's great for us. Two, it connects everything together, right? So if we're able to do things there, that means it's going to have also a large attack surface. And OpenVR was created so that today you have HTC Vive, tomorrow you have Oculus, the day after that you have Joe Schmo's VR system. You could still use it, right? So we were the first to coin certain attacks, like the immersive attack, the chaperone attack, the overlay attack, the disorientation attack, and so on and so forth. We're also the first to implement a proof of concept immersive attacks using OpenVR. We successfully implemented what we call the human joystick attack, which is kind of the more interesting attack, I think, out of all of this from my perspective, because I like the attacks that deal with human nature, and I think that's very interesting. And really our goal was to get people to think, to catalyze a movement. Like, you got to think about this. If you're going to do VR stuff, you got to start thinking about some of these things. So how do we do this? This is kind of the overall sort of high-level hierarchy of how we did things, right? We made an assumption, and which is a very easy assumption to make, right? And this is where researchers would argue, oh, it's not an easy assumption. No, it's a pretty simple assumption to make. Your computer was hacked. For me, that's an easy assumption to make, because once you understand how computers work, you know you can get into a system. However, I will make this claim that after this part of the paper, like this paper that I'm presenting very quickly, high level on, I'm going to show you some more work to show you that we don't even need to compromise your computer to do all of this, right? We don't. We can just use the underlying problems in some of these applications that lie on top of VR in order to gain full access and do very funky things with your system. All right? Are we good? Okay. But in this scenario that I'm presenting, we assume that the person has access to your camera. So what can you, or access to your system, right? So what kind of things can you do? Well, we're able to turn on the front-facing camera. All right? So that's a violation of privacy. We can stream video back to us as an attacker. We can see inside your room. We can even turn on the camera if it's disabled by the user. Okay? The second thing is, I was driving once, and I was like, man, the coolest thing to do is to just get rid of the chaperone and have people, hit a wall, right? I mean, maybe you don't think it's cool, but I think as an attacker person, I'm thinking, wow, that's kind of cool. Like, oddly enough, I think we have somebody in the audience that broke someone's hand in VR. Maybe you can tell them the story later. Not on purpose. So there's a chaperone attack. So what if you can just make the boundaries disappear, right? And that's what we did. Well, then things like this happen, right? All right, well, all of you, I'm going to assume that most of us know what ransomware is at this point in time, right? So what if we can create a new kind of ransomware that takes over your goggles? Right? Just place an image there, have it stay there. You can't get rid of it until you give us some money, right? And it's possible, right? Because of how how the layered infrastructure of OpenVR works, you can do things like that. What if I don't have to look into your room and just see it in a camera, but I can actually stream back every movement that you're making? I mean, how much of a privacy violation is that? And this is actually a real-time rendering of software that my student wrote that's doing exactly that, right? So we can stream location of where your hands are, where your headset is. Think about that, right? We can see in your room, and we could see exactly what you're doing. All right, so now on to the human joystick attack. The human joystick attack, and I can show you a video of this in a second, it's essentially this. Let me give you a background story of how we even discovered this attack, because we discovered it by mistake, right? At our university, there was a virtual reality symposium that had nothing to do with security. It was just like, hey, let's invite universities to do some VR cool work. And they knew that we were doing some work in VR, and they invited us. So we're like, what are we going to do? Show them how to hack VR? But we're like, okay, whatever, let's just go. So we set up, and as people were going, through trying all these experiences, Peter, who's a former student of mine, he put the experience on, and he just flashed things in front of them because of some of the attacks, and like, oh, see, we just took over your vision, things like that. And it was all script. Like, you just had a couple of, I think it was like either C programs or Python scripts. I don't remember. They just did some of these modifications, And a girl put the VR headset on, and he just looked at me for a split second. He's like, man, what if I change their virtual center? And he just all he did was he just changed the number, ran it, and we just saw the girl go like this. And we're like, hold on, did she just really move to where we told her to move? And he was like, I'm like, I don't believe you. Let's try this again. All right, just change the number to something else. And then a minute, not even a couple of seconds later, she went like this. And we're like, oh my God, did we just discover something? And is it cool? And I'm like, this is cool. And then, of course, he looked at me and he's like, okay, this is cool. And if any of you have done any human subject research, the automatic answer is this is not cool because of the amount of work I have to do with IRB and to get students enrolled. But then I told him, I was like, Peter, you have to do this because this is a really cool discovery and we have to just keep pushing forward on this. All right, so long story short, these are some results for you to kind of see certain things. At the bottom are different VR games like Longbow, Vortex, and Slingshot, Surgeon Simulator, and Guns and Stories. At the bottom, and this is, if you think of this as the room and you're looking from the top down, that's the headset data, right? So at the bottom is what they thought they did versus at the top is what they really did, right? At the bottom, they thought they stayed in that same location playing that Longbow game, but in reality, we were moving them from location A to location B, all right? So maybe most of you are thinking, you know what, Abe, it's kind of cool, not very interesting. To me, it's super interesting. Because right now, we live in a world where we can control people's thoughts by putting stuff on social media, right? Is the next iteration of that us physically telling people where they need to go and they go, right? Are we becoming so programmed as individuals that we might end up there? And maybe the hypothesis is true. So this is a quick video to show you the attack so you can kind of understand it a little bit. Okay. So what we do is, as you see in the image, there's a virtual center. And all we're doing is we're slowly moving the virtual center to a point of our liking. And what do humans do? They compensate for that. And because they compensate for that, we could move them where we like. The game that he's playing, all he's doing is he's standing in basically a circular area, and you don't need to move. All you need to do is just use your bow and arrow and fire at these items that are around. And all of a sudden, you start seeing him move until he hits the window. Okay, this is available on our YouTube channel. If you'd like to watch it later, please go ahead and do so. But the attack was pretty successful. It was successful across a range of games, and it happened with most people being unaware of the attack taking place. Okay, what if we can make you sick? Right? Now you're looking at this and kind of looks sickening just looking at this, but if you're in VR and this is happening to you, it doesn't feel great. Okay? Maybe you'd fall and break your hand. All right? So what's next? Well, why can't we put all of these things together to create a more impactful attack, right? What if we can compromise your system? Maybe there's no need to, and we'll talk about this in a minute. What if we look into your room? What if we can remove your safety boundaries? What if we could move you wherever we want, like maybe a stairway, block your vision, disorient you, and have you fall down the stairs? Okay? What if all of these things are combined into a mechanism that allowed us to do these things? Just as an example, right? So from a security practitioner standpoint, it's nice to find one thing, but you always have to find multiple things to create the impact and then try to leverage them in a way that's possible, right? Okay. Now, this has led us, remember the man in the man in the middle stuff we talked about earlier, where we're like, okay, some of the data was unencrypted. So this has led us to start working on this stuff. And we have a paper out right now that's under review. But we leveraged old attacks and new technologies, and we were able to do things that would just like be very interesting to most of you. And in specific, we looked at the big screen application, and of course, everything that we discovered was reported to them and supposedly patched, hopefully. But a lot of things are not as great as they seem. Let's just put it that way. So over there, does anyone know what we're doing there, just as an example? So this is the application, and you can join a room or like a public room, and then once you join that public room, again, big screen is this application where you sit down in VR with other people, you can watch a movie, you can do all sorts of other things, right? Does anyone know what cross-site scripting is? Yeah? This is just a sample cross-site scripting attack, right? We implemented it once and it affected all the users on the system. Think about that for a second, right? That's pretty gnarly, to say the least. So this was our primary implementation of what, again, I had another epiphany once. I was hanging out. I was like, I want to create the first man in the room attack. I don't want to create a man in the middle attack. It's called a man in the room attack. So we actually have a man in the room attack, which I'll show you in a second. And it's really us trying to explore what kind of old attacks might yield different results, okay? So there's two layers to this that we discovered. The first one is a cross-site scripting attack that affects multiple different people due to poor sanitization on application developers of the choices they make, for lack of a better word. So what are some of these things? What did they help us do? Well, RCE. Does anyone know what an RCE is? What's an RCE? Come on. Right, remote code execution. Right? If you can remotely execute code on a person's system, that's pretty cool. More importantly, we discovered something at a lower layer with the Unity platform, which is what most developers use to create games. And one of the big things we discovered is the open link function, the unity.openlink, passing it to URL. If you pass it a URL, it opens up a web browser, for lack of a better word, right? But if you pass it C users, it opens C users. Okay? If you pass it a URL/exe, guess what it does? It downloads the exe to the person's computer, right? So when we reached out to Unity, they were really excited. Not really. They even said, oh, that's just a feature. Like, all right, I don't know what feature you're talking about. And then before we released this publicly and it went viral and all this stuff, they just changed their documentation on the website saying, it could also do this. I was like, yeah, it's still not great. So we essentially created the first botnet of VR users by leveraging the weaknesses in the big screen application. We created a worm that was as simple as this. Okay? Nothing too crazy, but it works. All right? Self-replicating, does the job. So what are some of the things that we could do? Well, control infected big screen applications from a command and control server, which I'll show you in a second. Independently download and execute payloads, run any program, do remote REPL, gain control over part of big screen application, discover private rooms, invisibly join discovered private rooms, receive victim screen sharing, audio, microphone, video, persistently eavesdrop on them if they go to another room. We can send them a message that looks really legit for them to download the VR driver. Now we can execute our VR driver thing and stay in their system forever if we really wanted to, right? Hopefully they don't update and uninstall and do all these things, right? So a lot of very interesting things happen when you discover things like that. Of course, we can change their avatar, do all these silly things as well. So once you map out their infrastructure, you start understanding, okay, here's how they're doing things. And there's things like getting the state of the room by doing a /room state. You can see the blacklisted users, which is also not good. So we were able to discover usernames of people that were playing porn in public rooms. And they were banned for that reason, but now we know who those users are. So that's not very good that we shouldn't know these things. So the first thing that happened was essentially reverse engineering the signaling protocol across this platform for us to totally understand how things happen. And then once you understand that and you can decrypt some of the messaging, you get to understand the protocol and how it works. It's not that difficult, again. It's just programming, it's messaging, it's protocols. But the main thing here is while data is encrypted, there was no authentication, and in some cases, there was no encryption, which is a problem. All right, even though that in their code of conduct, they said we have no way of knowing what goes on inside because it is peer-to-peer and encrypted, which didn't seem to be the case from our perspective, at least. And then we started looking at the core application to see if we can reverse engineer it to do some interesting things. So we were able to dynamically load libraries because there was no integrity checking of any sort on these. And then we developed a proof of concept by patching those binaries and doing some interesting things with them. All right? And this is kind of what we did. So in able to create the man in the room attack, my vision when I was talking to the students is I want to put this VR headset on. I want to be in the room with 3 other people. I want to see them interact, but I don't want them to see me and I don't want them to hear me. Right? So by patching the application, all we did was patching things that would send data essentially to the servers, and we just stopped them from sending them. But we were able to receive the data that we wanted to receive to do the funky things that we wanted to do. All right, so I think it's important for you to just see this a little bit. Again, it's on YouTube, but I'd like you to just see some of the things in action, so to speak. So again, this started as a bunch of scripts that we did, and it ended up, I spoke to Martin Vondracek, who was visiting us from the Czech Republic in our lab. And I was like, listen, we need to package this into an application that can do all of these things. And this is when things got really interesting, because having one script that can do something small is not as impactful as packaging it into an entire application. I'm gonna skip the infection process and get to the meat of the. You can watch this infection process, okay? So over here are the discovered. You have the public rooms. You can discover rooms, and then you can start eavesdropping on rooms, okay? So what you do is you start poisoning, and when you poison, essentially what you do is what? You start some sort of a cross-site scripting attack against either the room name or the name of an individual that could then join other rooms, and then you can create a self-replicating worm because of it. So we showed the more difficult way of getting through that process, but it could be just as easy as creating one public room with a cross-site scripting attack in it. Okay, so in this case now, you can take that room and you can automatically see the zombies in the room, and it gets very interesting, right? Like being able to stream their computer screen in real time back to you. You have to keep in mind something very important here. The end user did nothing. The end user did absolutely nothing, okay? All the end user did was being a good person. They logged into their big screen app, they put their VR headset on, and they were just doing things the normal way they would do things. Okay? So we could start chatting on other people's behalf. We can make people admins if we really wanted to. We can toggle their audio. We can toggle their video. We can play various sound effects if you really wanted to. So to me, from someone my age group, this was really exciting because it reminded me of something called Sub 7. I believe that's what it was called, right? Sub 7. Do you know what I'm talking about, Greg? No? You have no idea what I'm talking about? Okay. So when we were kids, there was this Trojan that we would share, you know, on ICQ and things like that, and then they would allow you to open their, you know, their CD-ROM drive and things like that. And this was like, to me, it's like, oh, this is the new version of that in VR, and I got excited. So we just ran a command prompt, and it opened up on their screen, right? You can open up a folder there. So you're seeing like that's the attacker and that's basically the victim, right? We just download an exe on their computer and we just executed it. Then we could do something funky like this, where within their UI they'd receive some sort of a message that seems legit. Sorry, additional VR driver is required. Looks like it's part of the app. They would download it, and would be kind of cool, right? Kick users out. You get the picture, right? Okay. So then we're like, okay, most research or most attackers are not going to be focused on disk these days. A lot of people are doing things in memory. So it was very interesting for us to work on trying to get data out of memory so we could visualize potentially what artifacts we could retrieve from memory to understand the forensics of those situations, right? So that was kind of our take on this. And with IoT devices, you know, most of the time they're using ROTs, like real-time operating systems, and most of the stuff is just going to be in memory as opposed to being on the disk. So again, we took some well-known scenarios. We used VR, we took memory dumps, and then we started statically looking at where we could potentially find static data access points within the memory dump so we could know where we could pull data from, essentially, when we develop some sort of a module that we could use. Has anyone heard of volatility? All right, so we developed a volatility plugin as part of this, right? So this was the first time people have ever, like, nobody's ever looked at memory forensics of VR, right? So that was kind of really cool, and we did that. So this is the volatility plugin actually running, right? You give it a memory dump. I'm assuming it's going to run. Okay. So you run it against it. It finds the PID for the VR monitor. Then it finds the data structures. And then as soon as it does that, it takes the controller, the base station, and everything else, and it also plots it for you to kind of understand the last state that VR position was in memory, right? So now we've actually visualized where the headset is, where those where the controllers are, and also where the base station is by just pulling data from RAM, all right? And then we got into education. So we actually have lectures and labs that are openly accessible. If you want to reach out, I can send you this data. So these are just some of the labs. So like disk forensics and artifact analysis of VR, network traffic analysis of VR applications, and memory forensics of VR systems. We have some labs that are open. And lastly, while we just, our purpose was to attempt to use VR and see the security weaknesses, we actually created a game for people to play in VR to teach them about digital forensics. The sound is a little low. Is there any way we could push it up a little bit? So we collaborated with the Engage platform, and this is publicly available if you actually have a VR
Welcome to the
system,
introduction to cyber forensics lecture from the University of
And
New
this is
Haven's
supposed to be
Cyber
me,
Forensics Research and Education Group.
skinnier than
Now,
me,
before
as
we
you can
start
see.
this lecture, I want to
I'm
make
also not
sure
blonde.
that the audience understands that the lecture will not make you a certified digital forensics examiner by any means. This lecture is really just designed to provide a simple introductory level outline of what the digital forensics investigation process is. Our goal is to understand and define what cyber forensic science is, perhaps list the basics of a cybercrime scene procedure, understand what to do when a computer is on or off on a
So
crime
what we were
scene,
focused
or
on
maybe
is
what
something called simulated situated learning. So we give them a lecture, and then we throw them into a lab where they would have to bag and tag a crime scene.
in a virtual reality case to help you practice what you have learned. Thank you and good luck.
So now we're situating them, we're putting them in the shoes of a real investigator so they can potentially learn.
You're here. I'm Mr. Startup, the CEO of this company.
So this guy's
and
actually
I'm glad you
Irish,
joined our security team
just so
because
that
I'm in a bit of a pickle.
he's not
I've
making a
received
fake
an anonymous
accent.
tip that one of our engineers is going to leak the blueprints for our new VR time machine goggles. It's our flagship product. If we lose those goggles, it will mean the end of Think Small Technologies. Oh, I bet it's that Mr. Big Business across the road. He's the CEO of our main competitor, Big
All
Business.
right. So what we did is we built this, and then we wanted to test it. And this is a paper that's been submitted literally like 4 days ago. And the paper is called, Is My Digital Forensics Professor Better in Virtual Reality? Exploring DF learning in VR versus the physical world. So we actually conducted a human subject study where we put them in VR, and we also put another group that's not in VR, and we tried to see if the same amount of learning happened by doing pre-test and post-test and running some statistical analysis to see if it actually made a difference. The interesting thing is there was no statistically significant difference between putting people in VR and putting people, between people in VR and between people in the physical world. So that's a really good indication, at least initially, for us to be like, maybe we should be using more like the Oculus Rift so you guys can wake up in your dorm room or in your apartment and you don't have to, change your clothes and you just put that on. I can do the same thing from my home, put that on. It's like, all right, let's do a lecture, right? So maybe we should be moving more in that direction because I think it's also more interesting than the way we do online education now, where it's just basically using Blackboard or other learning management systems. And I think having more of an immersive environment to be in might create better learning opportunities for students. So in conclusion, we need security by design. We need this is a landscape for novel attacks that we need to continuously explore. It might be the perfect way to control humans in the future. And when I say XR, by the way, so I don't know if anyone's heard the term XR. XR means like VR, it means augmented reality, it means all of these things lumped together is X, right? So X is the unknown. We don't know what's going to happen next, right? So what are the next steps, right? What are the next steps? And this is why I co-founded an organization. Kavya Perlman is actually the founder. It's called the XR Safety Initiative. If you go to xrsi.org, in order for us to really start getting people to think about this problem, and they released an XR data classification framework not too long ago. Again, I'm the co-founder, but she's the head honcho on this initiative. And we hope that we can get more people to think about the problem and realize that it's something that we need to start looking at more closely as we do a lot more research in the security and forensics of XR systems. As any good academic would say, this is my reference list, and thank you very much, and I hope you enjoyed the talk. Okay.
I have a question. Basically, you're opening the gates of hell because the communication with the environment for everybody is just mostly by the senses that you have. You look, you see, you hear, you touch, and you taste and other stuff. But this one, sometimes it's getting some people in the deepest state that's basically cutting off from the reality. So I don't know, getting really involved in this kind of thing, you're going to get to the level of hypnotism. So you can program people, their mind, and then use it later on. And then basically you had before we had the drug which would control the mind. Now in combination with this kind of a system, this is going to be very dangerous. And you can add to that the subliminal communication that you can have with this kind of system. So basically, this is going to produce some kind of a people, even though to a lot of people this looks like some kind of a game or entertainment, it's going to make it really dangerous. So as I said, I was just listening, I was kind of confused that if you have you should have some kind of a commission, maybe the genie is out of the bottle, but they have to have some kind of a commission to see for the sale of these products and basically development of this kind of system, because it's playing with the mind of the people, and that's, I say, very dangerous. I don't know what you think about it.
So it's funny that you said that, because there's a company, and I forgot what they're called. It's called VR drugs, VAR drugs. So the idea of VAR drugs or VR drugs, or I forget what the company is called. Like their whole mission is, can we create alternatives to drugs in virtual reality, right? Can we stimulate and have the mind operate in a different way by placing people immersively in a different environment? So there's already companies that are coming out and saying we want to use virtual reality as a new type of drug solution for people. And I think that's, again, it's interesting that you bring that up. I think the thing that worries me is, like any other technology, there's positives and negatives. And what we have to be aware of is the implications of the deep privacy violations that can happen with VR. Because it's no longer just a cell phone that you're carrying. So with a cell phone, you can approximate the person's GPS location, right? But with a VR system, you're in their house, right? I know that this is a wall. Like the VR system knows that there's a wall there. The VR system can approximate where the floor is. So we're getting to the point where our devices can see inside of our house. And we're getting to the point where again, the screen is getting closer and closer to our eyes, right? Because right now it's a cell phone, you can pull it out and look at it, and we all do that, right? But in the future, you're just going to wear some augmented reality system that you're going to augment the world around you with other things, so to speak, right? So the solution, I think, is we do need some sort of a regulatory process for some of these things as they're happening. And I think that the technology has moved really quickly to the point where it's become mobile, and it's just going to keep getting smaller and better, in my opinion, as we move forward. And with the advancement in machine learning, especially, a lot of the systems don't need to have the same computational power to potentially produce the same results as like a very expensive system would. So machine learning is being used heavily in VR systems these days in order to make things just appear better for the user. And I think that there's going to be more things that we're going to see. But that brings up safety initiatives for machine learning and AI, which is another discussion, obviously, that we can have. So,
I mean, basically, if you continue, you are playing with somebody's psyche.
Right.
It's going to be tough to see what is going to be the fingerprints and stuff, particularly if something happens, and basically it's going to destroy the mind, and that's a very dangerous thing, because you don't know what the people are being controlled or not, or what's going to happen next. So that's what my concern.
And I think, and like I said, I think we need a better regulatory process for some of these things as they're starting to emerge. That's kind of the best way to do it. Yes?
I was wondering if there was like a safer version of the video game technology where someone could like sit down physically in a chair and interact with like a physical system, like a monitor.
So, are you saying that?
I was making a joke. I was saying that like physically sitting down at a computer would be a lot safer.
I mean, you're saying a joke, but I'm not actually. I'm not laughing because my mind took me to the new sort of HoloLens and some of the VR systems that are being used. Basically, they're saying that's what's going to happen in the future. You're going to have a lame desk that when you look at, it's not going to be lame in VR, right? Because you can touch the physical desk and then you could augment whatever you want on top of it, right? Because the new VR, so I mean, my mind took me to like where we really are going, right? So it's funny, but it's also like realistic, right? I mean, I think, and it's actually, as soon as I started playing with VR, I'm like, this would be a perfect way for me to change what my room looks like every other day. Because I don't want to get bored looking at the same thing, right? If you have, I don't know, you augment things. Like if I have a student that really bothers me in the classroom, I can just like change them into another student. I'm not saying I'm going to do that. I'm just saying, like, maybe you don't want to go down that route. Maybe right now you're really annoyed by Abe because he kept on bothering you because you were on your laptop. Like, just shut Abe off. I don't want to see him, right? So I honestly think that there's going to be tremendous opportunities in VR and AR in the future, but I think that we need to tread lightly because it's going to open a whole new avenue of security work. I mean, it's great for us, right? Security people, like this is great. Like, let's study the security of this. With the same token, I feel the same way about AI and machine learning. I mean, everyone's like, let's machine learning this, let's do this, let's do that. And it's like, oh, now it's like we have all these other layers of security that we have to worry about, security and forensics that we have to worry about. So it's just one of those items that new technology is cool, but we'd have to step back and understand what we're really doing. Yes?
I wonder how hard it is to get memory dump from these VR devices.
They were asking your...
I have to turn it on. Sorry. So I wonder, like, how hard it is to get memory dumps from these VR devices. Is there a unified interface or protocol for you to do this?
So the ones we worked on were running on Windows, so we were just dumping memory on a Windows system, so that was easy.
Okay.
But the newer ones are Android-based, so as long as you figure out a way to dump memory from an Android phone or Android device, there might be a way of doing that. Right?
Oh, okay.
So I think the Oculus Quest uses a Snapdragon and probably has an Android operating system running on it.
So I assume it requires some root permission to do this, like.
So yes. It's not impossible, as we all know, right?
Okay.
Sometimes it is harder, and sometimes it takes a couple of years for an exploit to come out.
Yeah.
But ultimately, like especially with the iPhones right now, I mean, I'm sure you've heard about, what is it called, Chekra?
Yeah.
Yeah, it's like all the forensic companies integrated Chekra like 1 week after it came out. Because you can just take an iPhone, dump its data, and you're ready to go. There hasn't been enough work, I would say, in the memory forensics domain of mobile devices. A lot of the stuff has been more on like Linux, Unix, and Windows. There's not enough memory forensics work on mobile devices. So,
I see. Thank you.
So the ARM architecture is not very well studied in that regard.
I see.
Any other questions? Anyone enjoyed the talk?
Awesome.
Yeah? All right, good. All right, thank you.